wonder what's in the water you drink? How is it made safe for drinking? Water you would use to water your garden or allow your dog to drink may not be something you would want to drink yourself. Also, the appearance of water can be misleading. Clear water does not always mean clean water. So what does water quality really mean? How we determine drinking water quality is very different from how we determine the quality of water in a stream.
It's primarily groundwater that we tap for our drinking water supply. Surface water interacts with groundwater. Sometimes it recharges the groundwater, and sometimes the groundwater recharges the rivers to keep them going, the base flow, during dry times. It is piped to our water treatment plants, and from there we do water softening. We add fluoride, we add chlorine, we add carbon dioxide to adjust the pH, and it goes through sand filtration, and then it's pumped into the distribution lines where we supply water to over 400,000 people. We analyze over 200 samples a day, and we have monitoring wells that total about 300 in the network. So it's really important for us to know if there are problems outside of the well field, and if there are problems, then we will get with Ohio EPA to make sure the problems are resolved, or at least the responsible party is being proactive to clean that up.
In this module, we're going to focus on stream water quality because our lives are affected by the quality of our streams, and we affect the quality of the streams with the choices we make in our lives. Also, because all water is connected through the water cycle, knowing about and protecting our streams will help to protect the quality of our drinking water. For our purposes, we are using the word stream to mean any flowing channel of water. Names such as river, brook, run, and creek could just as easily be used. So what does a stream need to have good water quality? Water quality of a stream depends on physical, chemical, and biological aspects. A key to understanding stream health is to realize the quality of a stream is a result of many factors outside of the stream channel. The watershed, the area of land that drains all of its water into the stream, will affect the purity of the water that flows into and feeds the stream. Different land uses in the watershed will either prevent pollution from reaching the stream, such as wetlands, or they will add to the pollution reaching the stream, such as an over-fertilized yard. The Qualitative Habitat Evaluation Index, or the QHEI, is one tool that scientists use to determine stream quality by looking at a stream's physical aspects. It looks at factors other than the water in the stream, such as the riparian zone.
So the riparian area is the area along sides of the stream. And naturally it would have trees, it would have grass, it would have bushes that would catch the water that was running off of the land into the stream. It would filter all of that water, it would slow it down. It'll also shade the water, which helps the temperature of the water stay lower.
When people build houses or have farms near streams, they often cut down the trees and shrubs in the riparian zone, which had provided shade to the water. The unshaded water will get warmer. Warm water holds less dissolved oxygen than cool water. This change in temperature will continue to affect the stream as it flows downstream. In addition to feeling warmer, the insects and fish that live in the water may become stressed or even die because of the lower dissolved oxygen levels in the water. Warmer water and lower dissolved oxygen will also make some stream organisms more vulnerable to pollution or other changes in the stream. Another factor that affects dissolved oxygen levels in the stream is an overabundance of nutrients such as nitrogen and phosphorus in the water.
Well, oxygen is the lifeline for fish and aquatic animals, and sometimes we see a depletion in dissolved oxygen, and we think most of that comes from runoff from farm fields where nitrogen and phosphorus accumulate, the water becomes nutrient rich, and you can have formation of algae. And algae is not necessarily a bad thing, but when you have surface water body that's choked with algae, the fish and aquatic animals have a hard time surviving in that. There are some animals that can withstand some pollution, but most cannot live very long if the dissolved oxygen is low.
The amount of nutrients, such as nitrogen and phosphorus in a stream, will have a large impact on how algae and other aquatic plants grow. Nutrients can come from fertilizers used in your yard or farm fields, from not cleaning up pet waste, and from grass clippings. These nutrients can potentially get washed into a storm drain and eventually into our streams. Too much of these nutrients will cause excessive algae growth. Eventually, the overgrown algae will die and be decomposed by bacteria. The bacteria need oxygen and as a result may suffocate fish and other aquatic organisms. So when a pollutant flows off of our land into our rivers, up in the headwaters, and the headwaters are in the top of our watershed, those pollutants can flow down through the system, through all the little rivers and streams, out into the main river and cause pollution issues downstream. And so we might think that on our residential lawn, we're just using a little fertilizer, but if we use too much, it will flow into the streams. And if all of our neighbors are also using too much, then collectively, that pollution is going to flow down and cause a much bigger problem downstream. In addition to temperature, dissolved oxygen, nitrogen, and phosphorus, there are several other indicators that scientists will often check when looking at stream health, such as pH, coliform bacteria, and turbidity. pH measures how acidic or basic a solution is on a scale of 0 to 14. Lower numbers mean a solution is more acidic, and higher numbers mean a solution is more basic. Pure water has a value of around 7, which is neutral. Typically, a healthy stream will have a pH between 6 and 8. Pollution can change the pH of a stream, which will cause stress, or worse for the animals and plants that live in the stream. Another pollutant that causes a great deal of concern for people who are playing in or drinking the water is coliform bacteria.
Coliform bacteria come from human waste, mammal waste more specifically. So it could be from lots of geese or from cattle in the stream or septic systems that aren't functioning properly. If people are playing in the water and it gets into their mouth, can cause them to be sick. And if we're pulling that as a drinking water source, then that can cause issues as well.
You may be surprised to find that sediment, which is soil that has eroded from our exposed land and stream banks, is the main pollutant in our streams. The most common pollutant into streams and rivers is soil. And it doesn't seem like a pollutant, but it can smother fish and insect habitat. It can make the water warmer. It can clog fish gills. And so it really is our most common pollutant that we see here and everywhere in the world. Fast-moving water can pick up, suspend, and move larger particles more easily than slow-moving water. This is why, after a rain, full, fast-moving streams look brown, almost like chocolate milk. They are carrying much more sediment than they do when the water is flowing more slowly. Have you seen these fences at construction sites? They are called silt fences, and their purpose is to keep the exposed soil at construction sites within a certain area. If silt fences are not used at a site, or if they are put up incorrectly, the soil from the exposed land at the construction site can wash into the street after a rain. That water, carrying all the sediment, will flow into a storm drain and end up in our streams. A storm drain is a pipe that flows into rivers and streams that has collected all the rainwater that runs off our parking lots, our streets, our sidewalks. And when it rains, that water goes down along the curb and gutter and down the storm drain and straight out into the river. And it goes out into the river untreated, so that anything that the rainwater picks up along the way, it could be oil that's leaked from your car, it could be that excess fertilizer from your lawn, it takes it out into the river. All that sediment causes the water to be cloudy or turbid, which is why scientists test for turbidity to help them determine stream health. So examining the land area around a stream and testing the water for a variety of factors are methods scientists use to determine water quality in streams. Another method used is to study the ability of the stream to support life, or the biological aspects.
When we want to find if a river or stream is healthy or polluted, we look for the insects that are living in the water. And we call those insects benthic macroinvertebrates. Benthic means they're bottom dwelling. Macro, they're big enough to see without a microscope. And most of those insects are in their nymph or larva stages, which means they don't have wings, they can't fly away, and they're easy to catch with a net. And so we look for those insects and identify them, and some of them can tolerate pollution, some of them can tolerate a little pollution, and some cannot tolerate any pollution at all. And so we put them into those categories when we identify them, and then we know if we find lots of insects that can't tolerate any pollution, that our river and stream is quite healthy.
Scientists, or citizens who are working with scientists, will often go back to the same section of a stream again and again to study the macroinvertebrate population for any changes. An increase in insects that are very sensitive to pollution and need high oxygen levels, as well as the presence of a greater diversity of insects, can show that the water quality in the stream is improving. A decrease in the diversity of insects found, or finding only the low oxygen and pollution-tolerant insects, can signal that the stream has had some kind of pollution or other stress since the last sampling check. Every day, each of us will make many decisions. When you know how your actions add up to affect the water quality in our stream systems, and how your actions plus those of your neighbors affect larger water systems, you've taken a crucial first step towards protecting our water resources.
Some of the things that you can do to help prevent pollution from flowing off of your yard or your driveway is to sweep off your driveway when you want to clean it instead of hosing it off. You can use less fertilizer and make sure that the fertilizer you're using on your grass doesn't harm the river and stream. We now can buy fertilizer that has fewer chemicals in it that won't harm our rivers and streams. We need to make sure that we apply herbicides or pesticides or fertilizers appropriately, and so not applying them right before a rainstorm when they could flow straight off into the river. We need to apply them where they have time to soak down into the ground instead of accidentally running off and out into our rivers and streams.
By using fertilizers only when needed, picking up after pets, helping to plant or maintain trees in a riparian zone, picking up litter, or joining a citizen science group who monitor the macroinvertebrates in a local stream, you can be a part of protecting the water quality in your local streams. You'll also be protecting the wildlife that call the stream home, the place you can enjoy fishing or canoeing, and the quality of your groundwater and drinking water. It's all connected.